All right, in this one we're going to be talking about linear equations, so slope-intercept, point-slope, slope, x-intercepts, y-intercepts, in standard form and parallel and perpendicular. Okay, so slope is either going to be rise over run, or it is also going to be y2 minus y1 over x2 minus x1. So in my first example, if I'm trying to find the slope between these two, if I want to label x1, y1, x2, y2, I'm going to do that with the second one too. So x1, y1, x2, y2. So this one I'm going to have 4 minus 7 over negative 2 minus negative 3. These two negatives will then change to a positive. So 4 minus 3, or 7 is negative 3. Negative 2 plus 3 is 1. So my slope for this one is negative 3. My next one I got 1 minus 1 over negative 4 minus 3. So I get 1 minus 1 is 0. Negative 4 minus 3 is negative 7. 0 on top is okay. It should equal 0. Okay, a positive slope should be increasing. A negative slope should be decreasing. 0 slope should be horizontal. And an undefined slope should be vertical. Linear equations make a line. That's why it says line in it. So an example is y equals 2x minus 1. When we graph that, it should make a line. We're writing this in slope-intercept form. So y equals mx plus b, where m is my slope, b is my y-intercept. Okay, so I got y equals, I replace my slope for m and my y-intercept for b. So if I was graphing this, it would start at negative 2 and it would go up 1 to the right 2, or I could go down 1 to the left 2. Okay, we're trying to get these into slope-intercept form, so you're solving for y. So this I subtract 5x first. So I got negative 4y. My x comes first because it's y equals mx plus b. Divide everything by negative 4. So y equals 5 over 4x, because two negatives make a positive, minus, oops, that's a 16. 16 divided by negative 4 is 16, then negative 4. This one I need to add 3/4 first to get that x over. So I have 1/2 y is equal to 3/4 x minus 1, because x comes first. To get rid of 1/2, we multiply everything by 2. I'm going to erase this top stuff so I have some space. So I have y equals, if I do 3/4 times 2 over 1, I get 3 times 2 is 6. 4 times 1 is 4. So I get 6 over 4x. And then we still distribute that negative 2 to the back end, so minus 2. If I'm graphing this, we need to y equals mx plus b, so let's move that x over. So y equals 2x plus 1, so we have to start at 1, and we go up 2 to the right 1 because they're both positive, or down 2 to the left 1. Okay, y equals 2x, we still need a y-intercept, so plus 0. We're going to start at 0, 0. We're going to go up 2 to the right 1, or down 2 to the left 1, and connect those dots. Y equals 6. My slope in this situation is 0, because 0 times x will then get me 0. So I would start at 6. When I do my slope, I got 0 over 1, so I don't go up any, but I can go right and left. So it should be a horizontal line. Okay, you can also never get it to be x equals a number, because it's y equals 6, so it should never cross your x-axis. Okay, find the slope and y-intercept. So when you're trying to find the y-intercept, you want to see where it crosses the y-axis. So if I'm looking, this crosses my y-axis at 3, and we need to find the slope. So you're trying to find how many you rise from one intersection to the other. So if I pick these two, I rise 3, going up is positive. I run, or to the right, is also positive. If I would have gone down, it was negative, and left is negative. So my slope then is 3 over 3, which is 1. So if I wanted to make my equation, I got y equals my slope plus my y-intercept, which was 3. Find the slope and y-intercept of this graph where it crosses my y-axis at 2. If I want to go from the point I just circled, I'm going to zoom in, from this point to this point, I don't go up any, but I go right 2. 0 divided by 2 is 0. So if I use the slope that I have, so y equals my slope plus, messed it up again. My slope plus my y-intercept. So 0 times x is 0. 0 plus 2, so it should be at y equals 2. Okay, point slope equation is y minus y1 equals m times x minus x1, where your points that you'll be plugging in are here, so your points given is x1, y1, and you'll also be plugging in your slope. So if I give you the slope and the point, you're going to plug it in, so I'm going to get y minus my y1, so my 2, equals my slope, and then x minus my x1, so -5. These two negatives will then make a positive, because there's always a minus sign that starts in there, but if I plug in a negative, it will change to a positive. And if I just want point slope, I leave it like that. Okay, so I have 2 points and I want to get to the slope-intercept equation, so there's 2 different ways to do it. So the first way, first of all, you have to find slope. So x1, y1, x2, y2. You always got to find slope first. So I got 8 minus 7 over 5 minus 3. Oops, that's a 2. 8 minus 2. 8 minus 2 is 6. 5 minus 3 is 2. 6 divided by 2 is 3. So my slope is 3. So you can do, to find the equation of this line, 2 different ways. You can do it slope-intercept or you can do it point-slope. So slope-intercept, we pick a point, so we're just going to use 3, 2 for both of them. So I got my y equals mx plus b. So I plug in my x, my y, and my slope. I don't know what my y-intercept is. So when I plug these in, I plugged in my y, I plugged in my slope, and I plugged in my x. We're going to solve it. So I got 2 equals 3 times 3 is 9. We subtract 9, so b is equal to -7. But that's not an equation I can graph. So I need to re-plug it back in with my slope and my y-intercept. That is now an equation I can graph. That's one way to do it. The other way to do it is plug it into point slope, and I think that way is easier. So I'm going to erase this. You should get the exact same answer. It also does not matter which point you pick. You should get the same exact thing. So if I pick the same point, I got y minus 2 is equal to my slope times x minus 3, my point slope equation. Got to get it into y equals mx plus b so I can graph it if I want to. So I distribute first. I got 3x minus 9, add 2, y equals 3x minus 7. Same exact answer. Standard form is x and y on the same side. Okay, so to get this x over, I would subtract it. And x has to come first. So I got -3 over 2x plus y equals -5. And then I want to have no fractions and decimals. So to multiply, I got to multiply something to get rid of that fraction. So if I wanted to multiply by 2, because that's my bottom number here, I will be able to cancel those. So then this becomes -3x. This becomes 2y. And we do it all the way past the equal sign, so we got -10 back there, okay? Because it needs to be the exact same equation, so what you do to one thing, you need to do to all of them to make it the exact same equation without fractions. So that is my standard form equation with leading coefficients that are whole numbers. Okay, x-intercepts cross the x-axis, so their points are going to be something like 3, 0, where there's always a 0 here. Y-intercepts is where it crosses the y-axis. So it would be something like 0, 4, where there's always a 0 here. So I'm finding the x and y intercept. So if I want to graph it, let's go ahead and get it into y equals mx plus b. So 5y equals -3x plus 15, because it has to go mx plus b. Divide everything by 5. So it becomes y equals -3 over 5x plus 15 divided by 5 is 3. So I would start, I'm going to zoom in, I'd start at 3, and I would go down 3, 1, 2, 3, to the right 5, 1, 2, 3, 4, 5, or I could go up 3, 1, 2, 3, to the left 5. So that means my x-axis here is going to be 5, 0, my y-axis is going to be 0, 3. Okay, so that's where it's crossing those. This is crossing my y-axis here, so that's the intercept, and this is crossing my x-axis here, so it's my x-intercept here. Okay, But let's do a shortcut. So if I don't want to solve this and I don't really want to graph it, let's go ahead and find a shortcut. So I'm going to erase all this here. Okay, so if I would have picked, let's say, that point there, that point is 0, 1. If I would have picked this point, it is 0, 4. So if you notice, all the x values are 0. Well, if I plug in 0 for x, I should get my y-intercept. 3 times 0, they cancel. So I got 5y is equal to 15. So y is equal to 3. And since I have the y, I put it in the y spot. Same thing, okay? We could also do the cover-up method where you could literally just cover it up and solve it and get your answer. So you do the same thing here. So if I wanted to find my x-intercept, that point right there is 1, 0. If I wanted to pick the point next to it, 2, 0. So all of my y values are 0. So this time, to find your x-intercept, we're going to plug 0 in for y. 5 times 0 will go away, so I got 3x is equal to 15. So x is equal to 5, so that point then is 5, 0. Gets you the exact same answer, okay? So you could literally cover it up and solve it to get your x and y. This only works if it's in standard form, though. Okay, so you could use the cover-up method, cover up one, solve it, cover up the other, solve it, to get your intercepts, but it has to be in standard form to use cover-up method. Okay, parallel line. So I'm going to graph 2x minus 1. So I start at negative 1. I go up 2, 1, 2 to the right 1, or I could go down 2 to the left 1. Okay, my other equation is 2x plus 3, so I start at positive 3. I go up 2 to the right 1, or down 2 to the left 1. And you notice that these are parallel lines, so they should never intersect, run alongside each other. If we look at the equations, parallel lines should always have the same slope. So that's how you're going to be able to tell if they're parallel. You look at their slopes to see if they're the same. Okay, perpendicular line. So if I start, this one's at negative 1. I go up 2 to the right 1, up 2 to the right 1, up 2 to the right 1, or down 2 to the left 1, down 2 to the left 1. My other one starts at 2 and goes down 1 to the right 2, down 1 to the right 2, or up 1 to the left 2. Okay, they should be intersecting and they should always make right angles, okay? The slopes for these are opposite reciprocals. Okay, so one's positive, the other one's negative. One's 2, one's 1 over 2. They reciprocal each other. Okay, perpendicular lines are always opposite reciprocals. So if I want to find an equation that's parallel to this line but runs through this point, I'm going to use the same slope here. So parallel lines have the same slope, so my slope is 6. It needs to run through this point, so I'm going to plug it into point slope because I have a slope and I have a point that it needs to run through. So I'm going to do y minus my y1, my new slope, and x minus my x1, but we're going to get it into a place that we can solve it. So my two negatives make a positive. We're going to distribute this 6. So I get 6x minus 6, subtract 3. So I got y equals 6x minus 9. So that point would run, or that equation of the line would run through that point, but also be parallel to that equation because they have the same slope. Perpendicular then, if I look at negative 4, they're opposite reciprocal slopes. So the opposite of negative is positive. The reciprocal of 4 is 1 over 4. Okay, here's the point that it needs to run through. So my new slope and my new point. So I got y minus my y1, my new slope, x minus my x1. Let's go ahead and distribute this. So I get 1/4 x, 8 divided by 4, so we got minus 2. We're going to add 5 to get it into my y equals mx plus b. Negative 2 plus 5 is 3. So my slope this time is that opposite reciprocal right there. So it was originally negative, it is now positive, and it is flipped. And because we use that point, it should be running through that point. So these two lines will be perpendicular to each other.